We will start with this problem that we have left in the last class. The length of time for one individual to be served at a cafeteria is a random variable having an exponential distribution with a mean of 4 minutes. See, mean is of 4 minutes. What is the probability that a person is served in less than 3 minutes on at least 4 of the next 6 days? There are two different probabilities to be found for this problem. First, we should find the probability distribution from, PDF, CDF for exponential distribution, the probability of getting probability that a person is served in less than 3 minutes should be found first, and then it should be found for at least 4 of 6 days. Okay. Here we go. First, I would like to show you information for exponential distribution. In the introduction, we might have seen that. In reliability theory, beta is the mean time between failures. Okay, so it's a mean time, can be considered as mean time, but when it is given as a discrete distribution, then beta should be taken as 1 over lambda, 1 over average. For example, in this problem, the mean is stated by exponential distribution, so therefore mean is beta is equal to 4. If it is given as Poisson distribution, we will take lambda is equal to 4, and then we will find beta is 1 by 4, isn't it? If we want to find exponential of that case, Poisson can be converted here if possible. So now our choice of beta is 4, not 1 by 4. Mean time of waiting. Beta is mean waiting time, so which is equal to 4. And what is the random variable x here? The length of time for one individual to be served at a cafeteria is a random variable. So random variable service time. Service time, isn't it? Waiting time in the queue, you can say. This is a part of queuing theory. So what is the formula for exponential distribution? From gamma distribution, when you put alpha is equal to 1, you will get this formula, e raised to minus x over beta for x greater than 0. From the formula function of f of x of gamma distribution, if alpha is equal to 1, you will end up with this formula. Therefore, here beta has been given as 4. Substitute the beta value to find property. Property of x is less than 3, isn't it? What is the probability? First, we should find the probability that the person is served. The service time is less than 3. So probability of x is less than 3. And our function starts from 0, so integration from 0 to 3. Upper limit is 3. Minimum lower limit should have been negative infinity, but this function is valid only for the values of x greater than 0. So we start from 0 to 3. F of x dx. Integrate this one. There are 0 to 3. e 1 over beta, beta is 4, e raised to minus x over 4 divided by 4 dx. So 1 over 4, integration of this one will be e raised to minus x over 4 divided by minus 1 by 4 from 0 to 3. So 1 over 4, 1 over 4 can be cancelled, but there is a negative sign, negative. Substitute upper limit 3, it will be e raised to minus 3 over 4. And when x is 0, e raised to 0 will be 1. So multiply minus inside, it will be 1 minus e raised to minus 3 over 4. This is the property for the first part. What is the probability that a person is served less than 3 minutes? Now, on at least 4 out of 6 days, we are going to find this probability. Waiting time less than 3 minutes has been found, and has been found here. We are going to find the next part. So remember this answer. We want, this is our probability of success now. Your waiting time is less than 3 minutes. So if the probability, if the new variable is defined y, we will remove this part. We will define a new variable y. Let y be a binomial random variable. Binomial random variable which is taken, which is a binomial random variable defined as the number of days a person is served. A person is served in less than 3 minutes. Less than 3 minutes. So for this y, the success is serving less than 3 minutes. So what is the probability of serving 3 minutes? Which is 1 minus e raised to minus 3 by 4. Which is 0.5276. Therefore, what is q? Because for binomial distribution, we want n and p. Q also important. Into q 1 minus p, which is 0.4724. And now the formula of binomial distribution: probability of x n p. Which is ncx p raised to x, q raised to n minus x, and x varies from 0 to n. What is the n here? N is 6. N is 6. And x is at least 4. So 4, 5, 6, there are 3 cases. So the probability of y greater than or equal to 4, at least 4 days. So greater than or equal to 4. For which we need to find probability of x is equal to 4, probability of x is equal to 5, and plus probability of x is equal to 6. So in this formula, take n is 4, x is n is 6, x is 4, first case 6 c 4, and p raised to x, what is p? P is given here 0.5276 to the power x, x is 4, and q 0.4724 to the power 2. Second term 6c4, what is 6c4? Which is 15. You can find 15 by calculating the combination. Second term, put x is equal to 5 in this formula. N is 6, 6c5, which is 6c1, which is 6, right? This value is 6. 0.5276 to the power of 5, 0.4724 to the power of 1. Only one more term, which is NC6. N6C6 will be 1, so we don't want to write the 6C6. It's 1 t power x, t power x, q power n minus x. N and x both are 6, so q power 0, q will not be there. Only p power x will be there last time. P, what is p? 0.5276 to the power 6. Now, later to solve this one, 6c4 is 15, 6c5 is 6. There is no coefficient, the last one is 1. And the answer will be 0.3968. That's the end of this problem. Next, random sampling. We have seen this kind of sampling in the introduction of this course, isn't it? But we repeat some of them. A population consists of the totality of the observations with which we are concerned. Definition: a sample is a subset of a population. What they mean already we have discussed again. If this is population, small part is sample. And then if the number of students in the college JUC is population, a small sample if I take a class is sample. Let's look at alternative ways of phrasing this. Our sample is the data that we are able to collect for our study. The population is the large group of data that we are trying to study, but it's too large for us to get all of the data. The sample is the data that we can get, but the population is the data that we would like to get if there were possible, if it were possible to get all the data. But generally, population is huge. We cannot analyze all the elements of the population. So we take a small part of it, that is small sample. Sampling must be done properly to prevent a bias which consistently underestimates or overestimates a population parameter. It is desirable to collect a random sample so that the data collected comes from independent observations and represents fairly the entire population. So sample represents only certain subgroups of the population, then it is a biased sample. For example, this assume that this is your population, and the population there are many different items. See, you will find some products we are analyzing, some defectives are there here, defectives and non-defectives. You have to take a sample. When you take a sample only from this area, this is biased. So your estimation will show that the entire population is defective. If you take a sample from here, it is biased. Then the estimation will show that the entire population has no defectiveness. So sample should have everything in its ratio, right? This is called unbiased sample. When you go for a particular case, it is biased, right? When we collect a random sample, we use a random variable for each observation of the sample. Some examples have been for random variable. If x1, x2, x1 be an independent random variables, each having same probability distribution profiles, then we can define them to be random sample of size n from the population profiles and write its joint probability as f of x1, x2, xn as product of all f of xi. Some important statistics. So if it is sample size, the mean is defined by this one. You know, already we have seen sum of all the data elements and divide by the total number of elements. Sample median is this one, the mid value. Even if there are two mid values, find its average. So when n is odd, your when I write 3, when I write 3, 5, 7, 11, 19, there are odd numbers. The mid value is 1. X n plus 1, 2, isn't it? So this x n plus 1, this is make it 6 and divided by 2 with third element. This is it, isn't it? If there are 6 elements, there will be 2 values in the middle, average of the 2 middle values. That is the second meaning. And mode. The simple mode is the value of the sample in which as value of the sample which occurs most often. For example, 2, 4, 2, 3, 2, 5, 2, 7, 8. The value that occurs very often, very frequently is 2, isn't it? So the mode of this data set is 2. So number of that is the value that occurred the most, the maximum number of times, isn't it? That is our mode. So we are going to find some mean median mode for the given data set. Suppose that symbol x1 is random variable. The lowercase symbol x1 is the numerical value of the random variable x1. Okay. Suppose that we have a random sample 4, 5, 6. So x1 represents 4, x2 represents 5, small x3 represents 6. So they are small values of x. And the mean is sum of them divided by sample mean. Sum of them, what is it? 9 plus 15 actually. 15 divided by okay, I will correct it. The mean is sum them up 4 plus and divided by 3. And that is 5. And what is sample median? Mid value. Mid value is 5. 4. If you arrange in ascending order, the mid value is 5. That is median. Here there is no mode, isn't it? So we don't find mode here. Sample variance is the same formula, x square minus n times x bar square divided by n minus 1, variance, standard deviation. All these formulas range, all these formulas have already been discussed. Now find a length, find a mean, median, and mode for this data set. What is the data? Arrange in ascending order. Arrange in ascending order. What you got to write is 5, 5, 5. There are 3 5s, isn't it? 1, 2, 3. Next, we get 6, 9, 10. Again, 10. What else? 11, 15. Do we have 10 values? 3, 4, 5. There is one more 10. 1, 2, 3, isn't it? 10 values are there. So find the average. What is the average? Mean. Sum of all these things divided by 10. The answer is, I'm writing the answer, you can check. Yes, 15, 21, 30, 30, 60, 86. I said 15, 21, 30, 30, 60, 71, 76, 86 divided by 10. So it is 8.6. Answer is given 8.6. And median, mid value 10 elements. So mid value, there will be this n is even, isn't it? So there will be two mid values, fifth and sixth. So, so this will be the middle value. Median will be 9 plus 10 over 2, which is 9. Mean is 8.6. What is mode? Most frequently appearing 10 and 5. 5 and 10. That's so same task you should do. I mean, yes, sum of all this. First arrange them in ascending order so that you can easily find the median. You are asked to only find mean and the median. So arrange them ascending order. The mean is mean x bar x 3.1. There are only 9 objects, so exactly middle value will be the median. Mean, sum them up divided by 9. That will be done by using calculator 3.2. Another problem, same, mean, median, mode. And just find the mean by adding all the data elements and divided by 15. There are 15 students. Arrange them in ascending order, find the middle value, that will be median. Mode, you can just observe which data is occurring the most. 0 twice, 3 comes 1, 2, 3, 4 times. 3 is the number that appears the most. So mode is 3. And I leave for mean and median to you. You can find median and mode. I mean mean and median. Mean is 2.4, median is 2. Mode is 3. That's it. Thank you very much.